This is SpaceTime Series 25, Episode 112, for broadcast on the 21st of October 2022. Coming up on SpaceTime, new evidence of liquid water beneath the Martian south polar ice cap, fresh hints of a possible Planet X in the outer solar system, and NASA now targeting November 14th for the next Artemis 1 launch attempt. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have revealed new evidence for the possible existence of liquid water beneath the southern polar ice cap of Mars. The findings, reported in the journal Nature Astronomy, are based on new orbital laser altimeter measurements of the shape of the upper surface of the ice cap. They show subtle patterns in height which match computer simulation prediction models for how a body of water beneath the ice cap would affect the surface. The findings agree with earlier ice-penetrating radar measurements, which were originally interpreted to show a potential area of liquid water beneath the ice, but which were later dismissed. The new study's lead author, Neil Arnold from Cambridge University, says the combination of the new topographical evidence, the computer model results, and the radar data make it far more likely that at least one area of subglacial liquid water still exists on Mars today. And that means Mars must still be geothermically active in order to keep that water beneath the ice cap liquid. Like Earth, Mars has thick water ice caps at both poles. The combined volume of the Martian ice caps is roughly equivalent to the Greenland ice sheet. However, unlike Earth ice sheets, which are underlain by water-filled channels and even large subglacial lakes, the polar ice caps on Mars have until recently been thought to be frozen solid all the way to their bedrocks. That's due to the cold Martian climate. But then in 2018, the ice-penetrating radar instrument aboard the European Space Agency's Mars Express spacecraft detected an area at the base of the ice sheet which strongly reflected a signal which was interpreted at that time as indicating a large body of liquid water existed beneath the ice cap. However, subsequent studies suggested that other types of materials which exist elsewhere on Mars could have produced a similar pattern of reflectance if they existed beneath the ice cap. Now, also, given the cold climate conditions on Mars, liquid water beneath the ice caps would require an additional heat source, such as geothermal heat from within the planet, and would have to be at levels far above those expected for present-day Mars. Now, these facts combined simply meant that more evidence would be needed before any conclusions could be drawn. On Earth, subglacial lakes affect the shape of the overlying ice sheet, its surface topography. It turns out the water in subglacial lakes lowers friction between the ice sheet and its bed, and that affects the velocity of ice flow under gravity. This, in turn, affects the shape of the ice sheet on the surface above the lake, often creating a depression in the ice surface followed by a raised area further downflow. So, the authors used a range of techniques to examine data from NASA's Mars Global Surveyor spacecraft, which looked at the surface topography of the Martian South Pole ice cap, exactly where the radar signal was identified. And their analysis revealed a 10 to 15 kilometre long surface undulation comprising a depression and a corresponding raised area, both of which deviate from the surrounding ice surface by several metres. Now, this is similar in scale to the undulations over subglacial lakes here on Earth. The team then tested whether the observed undulation on the surface of the Martian ice could be explained by liquid water at the bed. They ran computer simulations of ice flow, adapted to meet specific conditions on Mars. They then inserted a patch of reduced bed friction in the simulated ice sheet bed where water, if present, would allow the ice to slide and speed up. They also varied the amount of geothermal heat coming from inside the planet. Now, these experiments generated undulations in the simulated ice surface that were similar in size and shape to those observed by the team on the real Martian ice cap surface. The similarity between the model-produced topographic undulation and the actual spacecraft observations, together with the earlier ice-penetrating radar evidence, suggested there really could be an accumulation of liquid water beneath the Martian South Polar ice cap. It also means there must have been some sort of magmatic activity which occurred relatively recently in the subsurface of Mars to enable the enhanced geothermal heating needed to keep the water in a liquid state. It's all getting very interesting. This is Space Time. Still to come, fresh hints of a possible Planet X in the outer solar system, and NASA now targeting November 14 as the next possible launch date for the Artemis 1 mission to the Moon. All that and more still to come on Space Time. There are fresh hints today of a possible Planet X beyond Pluto in the outer reaches of the solar system. For decades now, astronomers have been searching the night skies for a mysterious ninth planet lurking somewhere in the darkness at the edge of the solar system. Fresh hints of a possible Planet X came to light when astronomers noticed unusual gravitational perturbations in the orbits of 13 Kuiper Belt objects. Those perturbations are thought to have been caused by interactions with an as-yet-to-be-discovered massive body. Kuiper Belt is a ring of frozen worlds, comets and icy debris circling the Sun out beyond the orbit of Neptune, the solar system's most distant planet. Based on its gravitational perturbations of these 13 small bodies, this undiscovered Planet X will be up to 4 times the size of the Earth, with around 9 times Earth's mass. And it would be on a highly elongated orbit around the Sun, estimated to last at least 15,000 years. Now, if it exists, this mysterious Planet X could be an interstellar rogue planet, captured by our Sun's gravitational pull. Another possibility is that it was stolen by our Sun's gravity from another star system. And there are also several models of planetary migration within our early solar system which suggest that as Jupiter and Saturn migrated out to their current orbits, their gravitational perturbations caused Neptune and Uranus to also move outwards, in the process swapping orbital positions and flinging a third ice giant that was with them either out into the Kuiper Belt or even beyond into interstellar space, where it now floats as a rogue planet. More recently, Michael Rowan Robinson, Emeritus Professor of Astrophysics at Imperial College London, took a fresh look at archival data from IRIS, the Infrared Astronomical Satellite Space Telescope, and he discovered something interesting, what appeared to be a previously uncharted object at the edge of the solar system. An early predecessor to the James Webb Space Telescope, IRIS was launched back in 1983 as the first orbiting observatory to look at the entire night sky using the infrared part of the electromagnetic spectrum. Over a period of 10 months, the telescope observed more than 250,000 infrared sources by detecting their heat signatures against the cold blackness of space. Now, if the IRIS data is correct, this object would be planet-sized, about 3 to 5 times the mass of the Earth, and orbiting the Sun at a distance of 225 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres. The problem is the IRIS observations weren't of very high quality, and they were made in a region of sky which is already full of filaments of galactic dust known as cirrus because of their cloud-like nature. Rowan Robinson later found a more recent comprehensive survey of the same region of the sky using the Pan-STARRS telescopes in Hawaii, and they failed to detect any object there, suggesting the IRIS object might not be real after all. Still, given the great interest in the possible existence of a Planet 9, it would be worthwhile checking to see if an object with Rowan Robinson's proposed parameters is lurking out there in the darkness. Now, if the mystery planet really does exist, it would be lying in the constellation of Cephus right now. That's a part of the sky well away from the plane of the orbits of the other planets, which all lie close to the ecliptic. A report in Australian Sky and Telescope magazine says if Planet 9 really does exist, the new Vera C. Rubin Large Synoptic Survey Telescope, which is currently under construction in Chile, may be one of the best tools to find it. Australian Sky and Telescope editor Jonathan Nally says the mystery of Planet 9 continues to enthrall sky watchers young and old.
Well, let me just say for a start that when I was a lad, all those centuries ago, there were rumours of a thing called Planet X, and you'll remember this.
And the Great Lakes froze over and the dinosaurs were all there. Sorry.
That's right. And Planet X back then, see, that was back when Pluto was a planet. So Planet X back then really meant Planet X, X as in the Roman numeral 10, because Pluto is the ninth planet, plus also X being the unknown quantity sort of thing. So there was thought that there might be another planet out there because beyond Pluto, a long way out, hadn't been discovered, so it's probably a very long way out or very dim because otherwise it would have been probably easily discovered. And this was because they thought there was an irregularity in Pluto's orbit that might be caused by a gravitational tug of another planet, but they eventually figured out that no, the observations of Pluto's orbit were a little bit imprecise, putting it simply. So Pluto's orbit was fine all along, and there was no need to invoke another planet out there. Not to say there couldn't be one, but that smoking gun, if you like, of there being some sort of gravitational influence on Pluto from an unknown big body out there vanished overnight, essentially. But it's sort of back again. So Planet X now still stands for the unknown, but not the Roman numeral 10 anymore. This would be Planet 9, now that Pluto's been demoted and we only have 8 planets, if it's really out there. And the reason that some scientists think there might be something out there, and a fairly long way out, like a long way out, is that there are some icy bodies, sort of Pluto-type things, way, way out in the outskirts of the solar system. And some of these have orbits that are quite similar to each other. And they think it's a little suspicious that these orbits are quite similar to each other. And some of the scientists think that there might be a big planet out there that is sort of gravity is shepherding some of these icy bodies' orbits into the sort of same kind. So they're trying to look for this thing. They think that's sort of slightly suspicious that these orbits would be like that. And if it exists, if it's out there, it'd be a fairly large planet too, about 10 times the mass of the Earth, and a long, long way out from the Sun, anywhere from about 300 to 800 times further from the Sun than the Earth is. So we're talking a long way out. I mean, Pluto is only about 30-ish times the Earth-Sun distance out from the Sun, so we're talking hundreds of times further out there than the Earth is from the Sun. So that's why, if it exists, it hasn't been found yet, because it would be very, very dim and very, very tiny at that distance.
And they think it's probably on a really highly elongated orbit, which could take like 15,000 years to complete one Planet Xian year.
It would take a long, long time. Yeah, if you're orbiting that far out, it would take a long, long time to orbit around the Sun. And it might not be in the same sort of obvious position or obvious plane that all the other planets are. So where do you start looking, and what do you look with? Because if it's that far out, it's going to be really faint, as I said, and really tiny. So you need some heavy-duty gear to try and spot that, or just lots and lots of time to be able to just scan the entire sky for as long as you like. And astronomers don't normally get given lots and lots of time on these big telescopes. You know, it's handed out like gold. They apply for it, and sometimes they might get a night here or a couple of nights there, or even half a night to do their observations, and to be able to devote weeks, months, years to any particular project just doesn't happen. Except that there are some new large telescopes coming on stream next few years, including one called the Vera C. Rubin Observatory, named after Vera Rubin, a famous astronomer who came up with the first evidence for dark matter. Now, this observatory is going to scan the whole sky, or all the sky that it can see from its latitude, in detail for 10 years. And what it will be able to do is, it's going to be a big scope, and it's going to be able to detect very, very faint things and essentially take snapshots of the entire sky night after night after night. And by comparing those snapshots from one night to the next, you can see if anything's moved in those pictures. All the background stars that effectively don't move from our perspective will stay in their places, but anything that is orbiting around the Sun, even if it's a long way out, will appear to move from one night to the next, or 1 week to the next, or whatever, in these really detailed pictures. So if there's something out there, and look, there's bound to be stuff out there, whether it's small icy bodies or this big one that's 10 times the mass of the Earth, then the Vera Rubin Observatory might find it within the next 10 years. So that'll be pretty interesting if we find a planet that big. And if there's one out there, there could be more. And it'll also raise the interesting question of, what are we going to call it? I wonder what they would call it if they found it.
What is the custom now for naming planets in the outer solar system?
Well, there are no planets in the outer solar system that we've discovered so far. We've got dwarf planets, but in this new categorization, in this new world of categorization, we now have planets and dwarf planets, and then you've got asteroids and what they call minor planets, basically, and you've got comets. But there hasn't been a planet discovered since Pluto was discovered, when it was considered to be a planet. And to be honest, sticking my hand up, I sort of still do, just for sentimental reasons. So I don't think there is a formal way to name planets, like a new planet.
So it's not like
in our solar system.
They've got to follow a character from one of Shakespeare's plays or something like that.
I don't think there is any rule for that. There are certainly rules and guidelines and things for dwarf planets and asteroids and comets and all those sorts of things. And there's some of them can get a bit complex, but and like moons, like when they discover new moons of Jupiter or Saturn or whatever, they follow certain traditions. And naming even features on planets, like so for instance, Venus. Every feature on Venus except for 3 is named for a female, either real or mythological. And they choose these names from cultures from all around the world. So you've got sea nymphs from this culture, and you've got goddesses from that culture, and you've got real people, deceased women from all different cultures around the place. So if they do discover this planet in the next 10 years or so, it's going to be, yes, as I say, interesting to what it will be called. I expect that what they will do is perhaps what they did around the time of Pluto and have a bit of a public contest and get names suggested. That quite often happens with things these days. And I hope they don't call a planet McPlanety Face or something like that.
Well, what they originally going to call Uranus George?
Yeah, after the king. That's right, exactly. Yeah.
Planet George. And hello to all the Georges out there, by the way. No offence intended.
No, exactly. And all the Uranuses out there as well. No offence to you either.
I was actually speaking to a NASA scientist recently about what does she call that planet, Uranus or Uranus. She calls it Uranus because it makes school kids giggle, and that makes them want to talk about astronomy, which is great.
Well, look, I remember back in probably 1985 or so, this debate started up in earnest in America. I think only in America. No one else cared anywhere else about what we were going. Because I used to get an American astronomy magazine back those days, and I used to read it from cover to cover when it came in every month. And yeah, there was this big debate going on because the reason for that was that the Voyager 2 probe was heading towards Uranus. It was for the 1986 encounter, flew past Uranus, and so yeah, this debate was going on. What are we going to call this planet? Because we've got to talk to our school kids and things. It's all a bit silly, I suppose, but, the 1980s were a different time. And, yeah, this sort of Uranus thing caught on and stuck. So if we were having this conversation in the 1970s, it wouldn't even be a conversation. Everyone called it Uranus. So it changed in the 80s when there was going to be a lot of talk about Uranus because Voyager 2 was going to give us our very first up-close views of the planet, because until then it had only just been a little blob through telescopes, really. We had no detailed view of Uranus at all. I mean, the Hubble telescope hadn't been launched yet. That wasn't going to be launched for another 4 or 5 years. So we didn't really know much about it. So it was never mentioned much. It was never in the news, and it just seemed to be a dull world out there. But then Voyager 2 flew past and showed us this amazing place, and it's been studied ever since. If we were having this conversation, I said, about 50, 60 years ago or so, then, we wouldn't even be discussing the name of it because everyone just called it Uranus. That's just the way things go. That's the evolution of language, I suppose.
As Kel Richards used to tell me, common usage is always correct.
Common usage is always correct.
Uranus and Neptune were both in opposite positions in the solar system before, and then when Jupiter's grand tour of the inner solar system ended and it moved back out again to its current location, the gravitational turbulence that caused flung both Uranus and Neptune out of their existing orbits into the orbits they have today. In the process, a third planet, which was thought to be in that group, a third ice giant, was either flung out of the solar system completely and is now a rogue planet travelling through interstellar space somewhere in the Orion Arm, or alternatively, it could be the missing planet X.
Well, that's interesting, isn't it?
Confined to the outer rim of the solar system.
Poor thing. Minding its own business. These 2 other planets ganged up on it and flung it out. It's out there, it's angry, and it's going to come back one day.
The angry ice planet.
That's right. There'd be a movie in there.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. Still to come, NASA now looking at November 14 as a possible launch date for the Artemis 1 mission to the Moon. The Kremlin carries out 2 more orbital launches despite the ongoing sanctions Russia faces. And later in the science report, an expedition to the Nord Stream pipeline leaks has found methane levels there 1,000 times higher than normal. All that and more still to come on SpaceTime. NASA says it'll wait until mid-November before attempting another launch of its giant Artemis 1 moon rocket. The space agency was forced to postpone its latest launch attempt and roll the 98-metre-tall rocket back from Pad 39B into the vehicle assembly building because of the danger posed by Hurricane Ian, which battered Florida earlier this month. NASA's now looking at a potential liftoff date between November the 12th and November 27th. A 69-minute launch window on November 14 is now considered the preferred target. Launching on November 14 would see a 25-and-a-half-day mission around the Moon and back, with the Orion spacecraft splashing down in the North Pacific Ocean on December 9. The unmanned mission will be the maiden flight for the Space Launch System, or SLS, the most powerful rocket ever built. Two earlier launch attempts, one in August and another in September, were both scrubbed, the August one due to a faulty engine temperature sensor, and the September one following a persistent liquid hydrogen propellant leak in the launch pad structure. While the Western boycott of Russian launches in the wake of Moscow's invasion of Ukraine has hit the former Soviet space industry hard, some missions are continuing to fly. A Russian Proton rocket carrying a new telecommunications satellite for Angola was launched successfully from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan, placing the spacecraft into geostationary orbit. The Russian-built ANGOSat-2 will provide communication services for the Angolan government for the next 15 years. The satellite's a replacement for ANGOSat-1, which failed shortly after launch back in 2017. But ANGOSat-2 has faced problems of its own, with its launch delayed by the COVID-19 pandemic and sanctions imposed on Russia over its invasion of Ukraine, which has held up delivery of key Airbus satellite components, including 57 waveguides for the deployable Ku and C-band antennas. So instead, those components had to be built locally. And just days before the Proton launch, a Soyuz rocket was launched from the Plesetsk Cosmodrome 800 kilometers north of Moscow, carrying the fifth GLONASS-K spacecraft for Russia's GLONASS satellite navigation constellation. The 950-kilogram satellite carries enough fuel for a 10-year lifespan and was placed into a 19,100-kilometer high orbit. The first satellite in the GLONASS constellation was launched back in 1982. Russia's network currently consists of around 24 operational satellites, with the new K-series gradually replacing the earlier GLONASS M-series. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A scientific expedition to the Nord Stream pipeline leak by the University of Gothenburg has discovered that methane levels near the Baltic Sea leak site are around 1,000 times higher than normal. The methane gas leak was discovered on September the 26th, and since then methane gas has continued to leak into the water. The methane gas is dissolved in the water, but when it reaches the surface, it transforms back into a gas form and is emitted into the atmosphere. Methane is a far worse greenhouse gas than carbon dioxide. Consequently, its effects on global warming will also be far worse. Right now, it's still unclear what kind of effects these high methane levels are having on marine life. For example, there are bacteria in the water there which can oxidize methane gas, causing them to grow and multiply. This all stems from a series of explosions which ripped open the two Nord Stream pipelines which supply gas from Russia to Western Europe through Germany. Germany especially relies on Russian gas for power generation after shutting down many of its own nuclear and coal-fired power stations and replacing them with solar and wind turbine renewable power. The problem is they don't work at night or when the wind stops blowing, and so they can't be relied on to provide baseload power. That's where the Russian gas came in. The pipeline's destruction by suspected sabotage by agents working for the United States removes a major income source for Moscow as it struggles to fund its ongoing invasion of Ukraine. There's been yet another study supporting weight loss benefits of a common diabetes drug. The latest findings, reported in the journal Nature, show that semaglutide could help overweight or obese people lose weight. The study, which was funded by the drug's manufacturer, found the use of a once-weekly injection of the drug led to weight loss equal to or greater than 5% of participants' body weight after 2 years, compared to people receiving a placebo. The only downside for those people receiving the drug was more frequent gastrointestinal adverse events than those in the placebo group, though they were mostly mild to moderate in intensity. While the drug's now been approved for weight loss use in Australia, doctors are being urged not to prescribe it, as it's leading to a shortage for people with diabetes. A new study has found that the Black Summer bushfires, which ravaged southeastern Australia in 2019 and 2020, released smoke particles into the Earth's upper atmosphere that contributed to the highest recorded temperature in the lower stratosphere since the early 1990s, and could have extended the lifetime of the Antarctic ozone hole. The findings, published in the journal Scientific Reports, are based on modelling which examined the effects of smoke aerosol, changes to the ozone layer, or a combination of both factors on stratospheric temperatures. They then compared these to controlled simulations of present-day climate. The authors say that the millions of tonnes of smoke released from the fires would have led to an increase in stratospheric temperatures of around 0.65 degrees Celsius, which is similar to the 0.7 degrees observed. The authors suggest that climate changes affect the intensity and frequency of fires, and that means we're potentially in for more atmospheric warming and ozone depletion as a result of more smoke particles being released. A new conspiracy theory claims that Hurricane Ian, which recently battered Cuba and Florida, was man-made. Now, don't get me wrong, weather manipulation is real. Farmers have been seeding clouds to generate artificial rain for decades. But conspiracy theorists claim it's progressed far beyond that, although they have no real scientifically verifiable proof to back up their claims. Their most commonly cited example is HAARP, the High Frequency Active Auroral Research Program, which is developed by the United States Air Force, the US Navy, the University of Alaska Fairbanks, and the Defense Advanced Research Projects Agency DARPA. HAARP was designed and built by BAE to analyze the ionosphere and investigate the potential for developing ionospheric enhancement technology for radio communications and surveillance. Put simply, HAARP fires a 3.6 megawatt pulsed or continuous signal in the 2.8 to 10 megahertz region of the high-frequency band into the ionosphere. And that signal changes ionospheric characteristics, which in turn affects how the ionosphere bounces signals over the horizon. These include VHF and UHF radars, high-frequency receivers, long-wave communications, and optical cameras. The research advances the study of the sorts of physics occurring in the ionosphere, both under quiet and geomagnetic storm conditions, and how that affects radio signals. But conspiracy theorists claim HAARP has the capability of triggering floods, hurricanes, thunderstorms, droughts, Gulf War syndrome, chronic fatigue syndrome, earthquakes, and even the downing of aircraft, although they've been unable to explain exactly how any of these events could be caused by an energy beam being transmitted into the ionosphere above Alaska. Tim Mendham from Australian Skeptics says it's all just speculation with absolutely no evidence.
There's people who are claiming that Hurricane Ian was man-made. Why exactly they wanted it to be man-made, I don't know. The interesting thing is they put up little documentaries all the time. There was one recently which was an in-depth 3.5-minute documentary that explained why this was happening and showed the history that everyone's trying to control the weather and that we can make a hurricane happen. Or we can direct where the hurricane goes as much as anything. This particular documentary was done by a guy named Dane Wigington. Dane Wigington is the founder of a website called Geoengineering Watch, and he's been campaigning for some number of years about sort of how the Earth is being manipulated by them, by powers that of various sorts. He should know because he's a former solar panel installer. But he's actually a very serious, angry-looking man. He's got a few books out, and you see his photo and things. He's never smiling very much, poor old Dane. Interesting thing in this 3.5-minute in-depth documentary, it keeps referring to the hurricane as Ian, almost like Ion, rather than Ian. And you think, that's weird, everyone's calling it Ian. Yeah, it's a person's name. It's part of a community of people claiming that the Earth is being manipulated, weather is being manipulated. Not quite sure why. Perhaps to keep people scared and sort of compliant with government, even though no one actually says it's government's doing it. It's a very strange phenomenon of paranoia and pseudoscience and general sort of just scare tactics that are sort of out there. So it's conspiracy through and through.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.